Hey guys, this is Mr. Larson here, and we're going to take notes today on midpoints and segment bisectors. Okay, so right now you should all have either a notebook out or a Kami document to take the notes and follow along while you watch the Ed puzzle. All right, let's get started. Okay, so the first thing is the definition of a midpoint is a point that divides a segment into two congruent segments. Okay, and that word congruent should stand out to you. Hopefully you guys have heard that in the past in math class, but for those of you who need a refresher, congruent meaning they are the same length. They are equal in length. So it's a point that divides a segment into two smaller segments, and those two segments are going to be equal in length. Okay, so now for a diagram, I'm going to use A and B as my endpoints and M, since we are talking about midpoints, to represent that midpoint. So this might remind you a little bit of the segment addition postulate, which you worked on a few days ago, where the segment addition postulate, the point M is somewhere in between A and B. I just want to point out what's different with a midpoint. We're talking about that point has to be directly in the middle. Okay, the next thing I want to show you guys is these tick marks that you see are now drawn, one on segment AM and one on segment MB. Tick marks are used in geometry to show congruence. So when you are given a problem and you see tick marks like that, that's indicating to you that those segments are congruent or they are of equal length. Okay, and the last thing here, labeling this. So first off, you could say M is the midpoint of segment AB. Okay, now the next thing here is segment AM is congruent to MB. Okay, so when you are using the symbol for a line segment, meaning two capital letters with that line with no arrows above it, you would use the congruent symbol, which is an equal sign with that sort of squiggle on top. So segment AM is congruent to MB, or you can say AM equals MB. Okay, and that last one where we don't show the segment symbol is where you use the equal sign, and AM equals MB, you're talking about the length of AM and the length of MB. Okay, so they're a little bit different. When you're saying the segments are congruent, you're just saying segment AM and segment MB are equal. When you say AM equals MB, maybe you're saying 5 equals 5. Whatever's that length of AM is the same as the length of MB. Okay, so an example, I have segment AB here where M is the midpoint. I know M is the midpoint because of the tick marks. Okay, I also know that M is the midpoint because the two segments that are created, AM and MB, are both of length 14, which means that M must be the midpoint since the two segments are congruent. Okay, so you could say AM equals 14, MB equals 14. When you don't use a segment symbol above the two letters, you're talking about the length. And then finally, remember your segment addition postulate. If the two portions are both 14, then AB must be the sum of those two. So AB would be 28. Okay, so now a segment bisector. Okay, so the definition first, a segment bisector is a point, ray, a line segment, or a plane that intersects a segment at its midpoint. Okay, so it can be a point, ray, a line segment, or a plane. And a midpoint or a segment bisector will bisect a segment. Okay, and that word is underlined because that might be a new term for you. The term bisect means to cut in half. Okay, so not only is the point or ray or line segment going through a segment, it's cutting it right down the middle. Okay, so a couple diagrams for you to copy down here, guys. First one, you have segment AB, which has midpoint M, okay, and you see that M is the endpoint of a ray MC. Okay, and then you also see on the bottom diagram line segment AB, which has midpoint M, and that is line segment AB is bisected by line L. You see the lowercase l there naming that line. So you could say ray MC or line L bisect segment AB at point M. Okay, so M is the midpoint. Midpoint is always a point, but the ray MC or the line L is the segment bisector. Okay, so now an example here at the bottom of the page. So we've called the endpoints AB again, and the midpoint is M. As you can see, AM is 3 units in length, MB is 3 units in length. Okay, so you know that M is a midpoint because they're both segments, AM and MB, are 3 units long. You also know it's a midpoint because you see those tick marks. So even if I didn't give the number 3 there, you still know M is the midpoint. Okay, so M is the midpoint, but also that line RT is a segment bisector. So you could say over here on the right, line RT bisects AB, segment AB at point M. Okay, but line RT wouldn't be the only example of a segment bisector here. M, the midpoint itself, is a segment bisector. Line segment RM, line segment MT, ray MR, ray MT, also line segment RT. Okay, so there's a lot of ways that you could have named the segment bisector here. Okay, remember from the definition, a segment bisector can be a point, a ray, a line segment, or a plane. So you basically had all of those examples in here other than a plane. Okay, guys, so now moving on to the next page. I kind of got into this a little bit before, but notice when line segment AC is bisected at point B, okay, you can say the segments AB and BC are congruent, where you use the symbol for a line segment with that line above the 2 capital letters and no arrows, and your congruent symbol, which is an equal sign with that squiggle. Or you can say the lengths of the segment are equal, where you just say AB equals BC. Okay, when you just use the 2 capital letters, no segment symbol on top, you're specifically talking about the length of the segment. So you might be really saying here like 5 equals 5, if that was the length of AB and the length of BC. All right, guys, so let's move on to some examples. Okay, so let's go through this first one here. So you're given that PR has a length of 12. You also know that RQ is the length 12 because of the tick marks. Those indicate that those 2 segments have to be congruent, which also tells you R is the midpoint. Okay, so when you're asked to identify the segment bisector, there's often more than one right answer. The midpoint itself, so here point R, is always a segment bisector. Okay, but also you could have said ray RT. You also could have said line segment RT. Okay, so, and notice here, guys, PR is 12, RQ is 12. That means by the segment addition postulate, the length of the total segment PQ must be 12 plus 12, or 24. All right, so now moving on to number 2, you see an X in there, meaning we know we're going to have to do a little bit of algebra. All right, guys, so the first thing is we know again that these segments are congruent because of the tick marks. Okay, so if you were asked to solve for X here, you would be setting 10 equal to X minus 4, and we would get X equals 14, okay, so by adding 4 to both sides. Okay, but you also knew that MQ equals 10 from the beginning because it has to be congruent to PM since they have those tick marks. Okay, so you could say the total segment PQ by the segment addition postulate equals 20. All right, and some examples of segment bisectors here. Again, you have the midpoint M, the line segment MN, and also the ray MN. All right, so we're going to do number 3 now, where you see both sides have variables. So neither segment is given to us. So take a second, pause the video and try and think about what you might do in order to solve for x there. So notice this is different than the last problem where we knew both segments had to be 10 units long because one of them was 10 and the other had that matching tick mark. But here you don't know the length of either of them since they both have x. So set the two segments equal to each other. And now we're going to solve for x. In order to solve for x, combine like terms. So I'm going to bring all my x terms to the left side of the equation. First by subtracting 3x. So you should get 1x or just x minus 1 equals 3. Okay, last step, add 1 to both sides. And you get x equals 4. Okay, so now that you've solved for x, you still don't know the length of pk or the length of kq until you substitute that x value back in. Okay, so here you can see substituting it in for pk, 4 times 4 minus 1 equals 15. Also substituting it in for kq, you get the same thing, 15. That should be the case. Since they both have tick marks, you should know that they should be equal, and that's a good way to check your work for these. If they're not the same, then you know you must have gotten the wrong value for x or done something wrong when you substituted it back in. Okay, otherwise those tick marks wouldn't be there if they were not congruent. Okay, using the segment addition postulate, that means since each segment is 15, the total is 30. Okay, and here there would only be two correct answers for the segment bisector, which is the midpoint K and line L. Okay, so now guys, take this time to pause the video and try number 4 all on your own. Okay, check that you can check that you got it right by substituting in the value for x, and you should get the same length for PB as you get for BQ. Okay, once you're all done, you can resume the video and check your answer. All right, guys, so you should have gotten x equals 2 by setting them equal to each other and solving for x. Once you substitute that back in, you should have gotten PB equals 7 and BQ equals 7. And that's a good way of checking and making sure you got it right. Since those two are congruent, you see the tick marks, you know that they should have equaled the same number. And by the segment addition postulate, if PB is 7 and BQ is 7, that means PQ equals 14. All right, and finally, there was a bunch of correct answers for segment bisectors for this one. You had the point B, line segments AB, BC, and AC. You could have said ray BC, ray BA, ray AC, ray CA. Also line AB, line BC, and line AC, which is all this same line, but there were several ways to name it. Okay, so you'll see for a lot of these examples, there are more than one right answer for a segment bisector. All right, guys, so make sure that you copy down all of these notes. If you need to rewind through any part of the video to get any of the notes you missed, please do that now. Have a great day.